Hello students, the purpose of this video is to get you acquainted with the derivative of the exponential function. So the derivative of the exponential function e is actually itself. So if you have e to the x power and you want to find its derivative, it is actually going to be e to the x. So one thing that we can do is find the slope of the tangent line, and that's not going to be the focus of this section, but I did just want to address it. So maybe I want you to find the slope of the tangent line at the point 0, 1, or maybe I want you to find it at the point 1e. If you're going to do that, you're literally going to take that x value and you're going to plug it in for x. And you see that I've gone ahead and replaced it, e to the 0, and anything to the 0 power is going to equal 1. And in the second one, when I find the derivative, I'm going to go ahead and plug in that x value. And I actually typed the same thing. I don't know why I did that. I apologize. So let me get rid of that and right on top of that. So this shouldn't say 0, 1. This should say 1e. But I would go ahead and replace the 1 with my x, and e to the first power is going to equal just e. And thus I have found the slope of the tangent line. All right, so moving on to finding derivatives. So by this point, you should be familiar with the chain rule. And with the chain rule is something called U substitution. And when I generally teach the chain rule, I don't begin by teaching U substitution. So I'm actually going to scroll through all of this because I want to get to the bottom. Let's see if I can grab some paper. It doesn't look like I can grab. Let me see if I can add some paper to this page. I don't think I can do that. I'm not sure, unfortunately, how to add. So that's okay. What we're going to do is we're going to go back really quick and we're going to make a new sheet of paper. All right, there we go. So when it comes to the chain rule, we may be given something like f of x is equal to x plus 3 all squared. And what we have learned is that we generally take the exponent and we multiply it to the front, and then we subtract 1 from the exponent, so that leaves us with 1, and then we multiply by the derivative of the inside portion, which in this case is 1. But I just want to give you another way to look at that. So this is the way we did it before. Let's think about it differently. So we have this function f of x, and it's equal to x plus 3 all squared. And let me call the inside u. So everything on the inside, I'm renaming it as u. So now my function f of x is actually equal to u squared. And I'm going to find the derivative of u prime, which in this case is just 1. And I'm going to find the derivative of f prime, which in this case is 2u. And then I'm going to take f prime and I'm going to multiply it by u prime. So f prime is 2u times u prime is 1. And of course, I don't want to write a final solution with the u in it. So I'm going to 2 times u, replace u, which u represented x plus 3. And now this is my final derivative. And what you'll notice is that this solution, 2 times x plus 3, is the same solution that I got over here. So essentially, when we're doing the chain rule, we are doing U substitution with it, okay? So, let's see. Nope, that is not our lesson. This is what happens when I try to switch back and forth in the middle of a lesson. I apologize. So, we are going to now do the same process of U substitution, but with exponential functions, okay? So, I'm going to start by saying, let's let u equal 2 to the x. And now the function that I'm working with, f of x, is just e to the u. And that's going to make it a lot easier for me to solve. So I'm going to look for u prime, and that's going to be 2. And I'm going to look for f prime, and that's going to be e to the u, because we just learned that the derivative of e to the x is e to the x. And although this is a u, it doesn't matter. It's just a different variable. It's the same concept. And now I'm going to take f prime and I'm going to multiply it by u prime because that's what chain rule says to do. F prime is e to the u prime is 2. I don't want to write a final answer with a u in it, so I'm going to replace the u back with what it represents, which is 2x. And then I can write my final derivative a little prettier as 2e to the 2x. And that would represent the final derivative of f prime of x. All right, let's look at another one, e to the negative 3x squared. So we're going to do the same thing. We're going to let u equal negative 3x squared. So now the function f of x is equal to e to the u. We'll find u prime, which is negative 6x. We'll find f prime, which is e to the u. And we're going to take f prime times u prime, which is e to the u times negative 6x. We're going to replace the u as negative 3x all squared times negative 6x. And then we can go through and multiply everything together and clean it up. And my final derivative equals negative 6xe to the negative 3x all squared. Looking at a second problem, 6e to the x to the third. Now, one difference with this problem is if you notice in all our previous problems, in the first one, there was an understood 1 here, but there was no other constant. There was an understood 1 in our second one and no other constant. But in this third problem, we have a 6. And the 6 is being multiplied by the e. So that's going to require us to use the product rule, because this is product that is going on. So utilizing the product rule, I'll write that here, product rule, we need to identify what is f prime, what is g, and what is g prime. So f is going to be 6, and g is the ex to the third. The derivative of 6 is 0. And to find the derivative of g, I actually have to go off to the side again, and I need to do u substitution. So I'm going to let u equal x to the third, which means u prime is going to be 3x squared. My function is just e to the u, so its derivative is just e to the u. And so when I do my f prime times u prime, I end up getting e to the u times 3x squared. And cleaning that up and replacing the u, I have 3x squared e to the x third. So in for g prime, I now can put 3x squared e to the x cubed. So for product rule, I have f prime g plus f g prime. So f prime is 0 times e to the x to the third plus 6 times g prime. And in my first term, because I'm multiplying by 0, this goes away. And if I take 6 and I multiply that by 3, that gets me 18 x squared e to the x to the third. And that represents my final derivative. All right, looking at another one, e to the negative x. So let's go ahead and let u equal negative x. And so now my function is just e to the u. And u prime is going to be negative 1, and f prime is going to be e to the u. So we're going to take f prime and multiply that by u prime. So it's e to the u times negative 1. And when I clean that up and replace my u, I have negative e to the negative x as the final derivative. Looking at e to the 3x. Again, let's let u equal 3x. So now my function is just e to the u. So u prime is going to be 3, and f prime is going to be e to the u. And we're going to take f prime and multiply that by u prime. That's the e to the u times 3. And when we clean that up, we have 3e to the 3x. As always, I encourage you to pause this video as I am moving briskly through these problems. I want to make sure that you're working these out on your own and trying your best to see if you can do these, and then playing the video to make sure the solutions are matching up. So we're going to let u equal negative 2x to the third. And now my function is just e to the u. So u prime is going to be negative 6x squared. And f prime is going to be e to the u. So I'm going to take f prime and multiply by u prime, which is e to the u times negative 6x squared. And when I clean that up and move things around, I get negative 6x squared e to the negative 2x to the third. And that represents my final derivative. And lastly, we have 4e to the x squared. So again, this is going to be a process of product rule. So thinking about f prime, g, and g prime. F is going to be 4, and g is going to be e to the x squared. F prime is going to be 0, and g prime is going to require me to go off to the side and do some u substitution. So I'm going to let u equal x squared so that u prime is equal to 2x. So my function is e to the u, so the derivative of that is e to the u. And when I multiply e to the u times u prime and clean that up, I get 2xe to the x squared power. And so when I go back, I can plug that in for g prime, 2xe to the x squared power. So product rule states f prime g plus fg prime. That is 0 times ex all squared plus 4 times 2e or 2xe x all squared. And the first term is going to go away because that's 0. 4 times 2 is 8xe to the x squared. And that represents my final derivative. Okay? All right. Hopefully you're feeling good and comfortable with these derivatives, but I do want to take a look at some other problems that just may be a little more complicated to make sure that you're feeling really good about everything that we're looking at, okay? So let's do another one. Let's look at the problem f of x is equal to 4e. What do you think the derivative is going to be to this problem? If you said 0, you are absolutely correct. The reason why is you want to remember that e is just a number. So when I have a number multiplied by another number, the function is just a number. It's just a constant term. And we know that the derivative of any constant term is going to equal 0. Let's take a look at this function, e to the 2x minus 1. I want you to see that it is possible for you to have an exponent that is written in the form of an equation. We're going to follow the same process. We're going to identify a u, and we'll call it 2x minus 1, so that now I have the function e to the u. And my u prime is going to be 2, and so my f prime is going to be e to the u. And we're going to take f prime and multiply that by u prime, and that is e to the u times 2. And clean it up so that I get 2e to the 2x minus 1. And that represents my final derivative. So the process looks exactly the same, even if you have a function within your exponent. Continuing on, let's look at something like the function x e to the x. So again, this is going to be product rule because I have two things that are being multiplied together. The x is being multiplied by the e to the x. So I need to go and think about, okay, what is my f, what is my f prime, what is my g, and what is my g prime? So my f is x, and my g is e to the x. And the derivative of x is just 1, and the derivative of e to the x is just e to the x. So that then when I go to plug in my product rule, which is f prime g plus fg prime, I just have 1 times g plus fg prime. And I've now found the final derivative. You also want to be strategic when looking at various problems and how you go about solving these. So if I had f of x is equal to e to the x minus e to the negative x, and I divide all of this by 2, I want to think about the different ways that I could write this. One thing that I notice is that I have a fraction here, and maybe I don't want to write that as a fraction. I understand that all of this is together, and there's an understood 1 here, so technically I have 1 over 2, which is just 1/2, being multiplied times e to the x minus e to the negative x. And then I could distribute in that 1/2 to both terms and have 1/2 e to the x minus 1/2 e to the negative x. And now that I have 2 terms that are just subtracting, I can literally find the derivative of this first term and then literally find the derivative of the second term. So looking at this first term here, I'm going to do my f prime, g prime. F is 1/2. G is e to the x, so f prime is going to be 0, and g prime is going to be e to the x. And so when I do f prime times g, that's 0 plus the 1/2 g prime gets me 1/2 e to the x as the derivative of that first term. Minus, and now I'm going to find the derivative of the second term. So I'll do that over here in blue. So same idea, do f prime, g prime. F is 1/2, g is e to the negative x. So f prime is going to be 0, but g prime is going to require, because this is a negative x, it's going to require some u substitution. So now I got to go off again, and I got to say, all right, let u equal negative x. So now my function is e to the u. So u prime is going to equal -1. F prime is going to equal e to the u. And multiply the 2 together and clean it up. That gets me negative e to the negative x. So now I can go fill that in for g prime. Negative e to the negative x. And so when I do f prime times g, that's 0. And then when I do the fg prime, that gets me negative 1/2 e to the negative x power. But I know that a negative and a negative make a positive, so I can go ahead and clean this up as 1/2 e to the x plus 1/2 e to the negative x. And that represents my final derivative. So as you're doing these problems, it's super important that you think about creative ways to rewrite the problems and then go about solving them. So just to give you one more example, and I'm not going to actually go through and solve it, but I just want to give you an idea about how you can alter problems to make them look a little different. This problem right now is written as quotient, meaning you'll have to use the quotient property. But if you really want to avoid that, remember that we can always move something in the denominator to the numerator and the exponent becomes negative. And so this is an equivalent way to rewrite the problem so that now you have product rule if that's something you feel more comfortable with. As always, I hope you found this video helpful. If you have any questions or concerns, please don't hesitate to reach out, and have a wonderful rest of your day.